Good morning, good afternoon, good evening. Welcome to the net.lol, where we like to bring you a little flavor with your networking as well. That's what our goal is here, I think. So I'm joined with my esteemed co-host, Tom Nadeau, Brent Salisbury, Dave Tucker. I'm Kyle Mestry. And today we are very pleased to have with us as a guest, Ian Wells. Ian, would you like to tell us a little bit about yourself?
I guess. I actually work with Kyle, and I do NFV for a living, which covers a multitude of sins. Software-defined networking, trying to build platforms that run network functions, trying to build network functions.
Wait, are you the person we can blame for Etsy?
Thankfully, no. I didn't have a great deal to do with that. I was just curious. I have to implement it. I didn't write it, so it's not my fault.
That seems reasonable at least, but yeah, you have been doing this so how many years have you been doing this? This has been a long time.
Actually.
A decade?
I mean,
has it been a decade? Maybe.
Not quite, I think. But, well, it depends on how you count it, actually. We were doing it before it was called NFV, actually, before the Etsy standards came out and called it NFV, before that white paper was published. But, yeah, I mean, it's been a long, long while at this point. I guess it probably came actually slightly before I got involved in OpenStack. We were doing, Cisco builds a product called Viral, which is basically a kind of experimental routing lab. And so I got involved in the early days of that, basically making a platform on which we could run these virtual routers and, wire the networking together and make the whole thing hang together and actually pass traffic. So that's kind of NFV. I mean, they're network functions. They were virtualized. I think that counts.
Hey, if you're running virtual CSRs, that's NFV, I think. So seems reasonable. Yeah, so that was back in the day when everything was virtual, right? We were making that transition from hardware appliances per se, and we're moving it over. I think the first step of that was let's just lift and shift the operating system off the box and drop it in to a virtual machine. And how did that work out?
So it worked. I mean, you can't debate that, and it had its uses. If you think about the environment we're in those days, then with AWS, obviously, is long time virtualization platform. If what you want to run is a router that does more than AWS's networking would offer at the time, then lift and shift of the operating system and basically faking out or replacing the hardware that would forward packets with a data plane of some variety, you got functionality that otherwise you couldn't get in those circumstances. And it moved rapidly from there to, well, what about the things that your average telco runs, a service provider? And they fall into various categories. There are a lot of things which are always going to work better as physical devices. If you're doing fairly unexotic things like just getting traffic from A to B, there's no reason to virtualize that today. I can build a chip that will move packets much faster with a lot less consideration for each individual packet in a chip. And to be fair, in the way the world's evolved, then network processing units still exist. We get smart NICs nowadays of various flavors and different complexities, and it really is just sort of iterating on the hardware side of things and how you can use that. But the one category that really did sort of show or develop rapidly in virtualized functions is mobile networks. If I'm trying to deal with 1 million subscribers on my mobile network, I have a lot of data to think about. I have a lot of individual connections that I'm going to have to think about. And dealing with a lot of data in NPUs is incredibly expensive. So it turns out that that's the place where virtualization really did pay dividends.
Yeah. And when you start to talk about that level of density in terms of customers, the next logical step might be to start to think, well, look past virtualization. And of course, everyone's going to jump into containers at that point, I feel like, as well, right?
And we've all been thinking hard about that, I have to admit.
But that's a question, right? I wanted to ask you, right? Are containers appropriate for everything in networking? Because that seems to be like, certain corporate strategies these days
Yeah,
at
so
various vendors, let's
there are
say.
things here. There's a lot of unpicking in that. Um, Virtual machines and containers do different things, but they're only part of the story. I can run a virtual machine in VMware. I can run a virtual machine on my Linux box. I need a framework to decide what virtual machines to run, and I also need to figure out how I'm going to connect them, network-wise particularly, but also things like storage to figure out what I'm going to make them do. And containers are no different in that regards, right? We started with Docker. It gave us fairly basic, I'll just put everything on a network, a flat network. We moved on to things like Docker Swarm, Nomad, Kubernetes, and the networking always existed. It was never terribly dramatic. From a perspective of actually getting the job done, I need to manipulate either funny protocols like BGP is not, and I'm going to use cloud native in the general sense, either a virtual machine or a container cloud. It's not terribly cloud native. I can't just swing my BGP connection one place to another and hope everything will continue to work. If we start talking mobility, they absolutely love SCTP, which is something at the level of TCP, a particularly unusual protocol that's really, when it's used, is used knowing full well that you've got control over the whole network architecture, but it's unusual and it has, you can't just load balance it like you would an HTTP connection again. It's odd. And then a lot of things that we do in NFV are actually examining individual packets. And we worked out from the very early days that if what you're doing is looking at a packet and saying, I'll fiddle this bit and I'll send it in that direction, that I need a data plane that's really quite tightly integrated with the hardware. Linux kernels can do it. It's not that it can't be done, but they're not necessarily the environment you would choose to do it in. And also, frankly, a Linux kernel, either it's got to offer you a generic set of features because, again, it's running at high levels of privilege. Your Linux kernel crashes, then you don't really get to see what just happened. It all basically falls over and everything that's running on that box. So running it as a program rather than as part of the kernel has its advantages as well. So I can do both of these things in virtual machines and containers, right? If I'm running in a virtual machine, there's a process hiding in there that's doing the work. I can just pull it out and put it in a container instead. But it does leave you with a whole bunch of questions. How am I going to attach it to the network, being perhaps the biggest one that
Well,
we're
what
still
if it is the
basically fighting
network?
with?
This
Yes,
is kind of
when it
tease
looks
out
like a
here.
part of
That's
the
right.
What
network.
if it is the infrastructure, you know?
Yeah, exactly. When it looks like a part of the network and you're trying to almost not discriminate between what the platform's doing for networking and what that application's doing for networking, you get a very complex question there. And then exactly how I orchestrate that as well, and what the platform is doing for me and where the platform should stop and say, that's your problem now. Those are the questions that I think we struggled to resolve. In virtual machines, we came from a world where at least when we got to OpenStack, it didn't start here with AWS, but when we got to OpenStack, we were basically everything's a switch, right? We can deal with networks because they all look like switches and we know how switches work. And while we might not necessarily use switches in a telco network, we at least knew how we could, deal with them. In Kubernetes particularly, it solves a different problem, right? Application developers, and I've been there, I have been an application developer, they're not interested in fine-grained network control. In fact, if you put a firewall in the middle of an application, then what you will find is a whole bunch of engineers busy trying to work out how to get around the firewall because it's an incredible
I was going to
noise.
say, you'll find that it breaks the application, right?
Yes. How many times, if you're old enough, you will remember running your SSH servers on port 443 because your corporate firewall would let it through without asking questions, which is effectively an application guy or a software guy figuring out how to work around what they conceive as network damage. The network's not doing what it's supposed to do. Kubernetes basically said, well, if what I'm basically trying to get from my application is reachability from A to B, regardless of what A and B is, then that's the only bit of networking that I have to design. Nobody cares if it's layer 2 or it's layer 3. Nobody really cares whether NAT's in there or not for the most part, and a whole bunch of other things. I can do things that would make network engineers cry. And it's all perfectly acceptable because I'm not actually targeting this at network engineers. And then when I try and use it for network engineering, it makes me cry and I end up with a whole bunch of problems.
Well,
So
this is
that's
fair
one of
though,
the
because
things.
network engineers make application developers cry. So it's only fair that
True.
there's this tension
Yeah.
between them. But you're right, and I think you're bringing up a core fundamental problem is, is Kubernetes the right platform for this? And we're talking about CNFs here, right? Container network
Yeah.
functions. Is it the right platform for that?
Um, and that's a complex question to answer because Kubernetes is not a static point in time. It's not a fixed thing. It evolves and develops. It does more now than it did 5 years ago.
Well, not just that. It run. I mean, one of the reason why I'm picking at this, I had this epiphany last week around this, and I was like, wow, we're working on a lot of edge stuff these days, and really the question to ask Kyle was not the question to ask is Kubernetes applicable everywhere, right? If you were going to use containers for that, for example, can I run a full-blown Kubernetes on a Raspberry Pi, or something.
You can, and I have.
Exactly.
It does work.
But
It's
would you want to run it there? And is it? Are we
yeah.
trying to bang a round peg into a square hole? Is
Yeah,
there
I
a
think
simple
it's.
solution?
Let's look at this. We've got. I will go with 4 form factors that we could choose from today. We could basically, setting aside actual physical network devices, I could just run it on a server, right? Let me not virtualize this at all. Let me just use the whole server. I have clean access to everything. I can get the full capacity of the server working for me. I can run it in a virtual machine, and I do lose a bit of performance running it in a virtual machine, but I have a defensive boundary, which means that I can share my physical server among multiple virtual machines doing different things. And one of the important things to remember here is it's not exclusively about how well I can design my software. It's very important to consider whether or not that trade of performance, because everybody wants as much performance as possible, gets me something in return. And here it gets me operability. I know if I've got 2 virtual machines, I'm effectively declaring that whatever my left virtual machine does will not affect the one on the right. They're completely independent of each other and their software, and I've never written a piece of software that hasn't had a bug in it ever, and nor has anyone else, if we're being honest.
Nor has anyone else.
When that left-hand virtual machine basically does whatever it's going to do, and it will fail in new and extraordinary ways every single time, the right one is completely independent. So I can actually isolate the problem that I've got. I can narrow it down without having to consider the fact that they're running on the same box.
But that's
In
what I'm getting at,
containers-
for example, is if you have a use case where you no longer need the sort of generic capability to run any workload, let's just imagine there's really one workload, a collection of containers. But it's really kind of, let's imagine you took a virtual machine, you blew it up into its little atoms, made it into containers. If that's the only thing you can run it, and that's the only place you can place that workload, my question is, why do you need Kubernetes?
Yeah, there are various reasons why you might want to use it. One is that you might not be running that. I think network functions break into, uses a ton of servers, not just one, uses a server, and uses a bit of a server. So that's one part of this, which is if I'm only going to use a bit of a server, then I want to run multiple network functions on the same server. And as you were talking about earlier about edge, right? The further I get to the edge, the more likely that's going to be the case. I don't have torrents of traffic. I have dribbles of traffic at some edges, at least. And so I actually do want to make use of my server by subdividing it. And if what we're saying is this is the same kind of network function, I'm just running it at different scales, then having a platform that allows me to use multiple servers, but also a little bit of the server, means that I only have to write my application in one way, and it will run in both circumstances. And both virtual machines and Kubernetes.
Well, this is kind of what I'm getting at too. Is like there's this mad rush to containerize everything. Wait a minute. What if running the thing bare metal is really sufficient?
Yeah, I think that this is it. This is it. You have to have this broader discussion of what are you trying to accomplish. I think we're deviating a bit, but we're going down the path of Kubernetes for everyone. You get a Kubernetes, you get one. It's like, hold on. Let's think about the problem. Let's figure it out because I might want it.
Let's just remember, right? Containers and Kubernetes are 2 different things, right?
Exactly.
Kubernetes are basically a packaging format.
That's the key.
And I'm going to plug here a little project that I've been maintaining for quite a few years called LinuxKit. So the fundamental idea behind Linux Kit was that you could take a bunch of containers and you could build them into your own operating system, which will run on bare metal or will run on AWS. So then it kind of breaks down that boundary. If you're only going to need to deploy once, or maybe you want to deploy and have something immutable and then, throw it away and then deploy a new one, you can do that with containers. It's fine.
Well, let's talk about how Kubernetes is used for a moment, because I think this is something that people forget.
Yeah.
Kubernetes is an open source project, so it doesn't necessarily get sold to people. But if we're looking at the audience for Kubernetes, it's developers. I am trying to give developers a tool that lets them design their applications in a slightly better way, a more structured way, with individual components with clear separation. Again, container boundaries are not as strong as VM boundaries. So in that regard, if I'm trying to run high performance bits, then there are some adaptations I'm going to have to make. But effectively, I'm giving an application developer a tool that makes it easier for them to develop things. If we look at the way that we want to use it in the telco world, if I'm saying that I want to run a single platform with many different applications on, that is not selling to a developer. That's selling to a platform provider, if you like. Someone who's going to basically then choose 6 apps and run them all on the same Kubernetes.
Or a network operator who's got to run that after.
But Kubernetes to date has really been, I'm running an app on a big Kubernetes cluster, not I'm running 6 apps, which means that when it comes to it, I might tweak and choose exactly how I'm putting Kubernetes together. If Kubernetes goes wrong, then it is the app architect's choice to have used it, and it's the app team's problem to fix. If I separate those two things, then I'm looking for a platform that I can trust to run multiple applications and keep them well segregated. I'm actually making a bunch of problems that I don't think have necessarily been primary in Kubernetes developers' minds when they first came up with it.
Yeah,
and
I also
think that plays to Dave's point as well, because he's saying I
ahead.
can do this. I can basically take a Linux box, run a layer of software, run little bits and pieces on top of it. I don't have to use Kubernetes for that. Absolutely true. On the other hand, the question is, which of these tools, any of them will do, quite honestly, which of these tools is the one that I want to take forward and use for, which is the closest to the mark for what I'm actually trying to accomplish?
Yeah, it's quite a funny point, actually.
The assertion I'm trying to make is that it's probably, and I said this a long time ago, is that we're going to live in a heterogeneous universe, right? And really what I didn't quite get, and this is like when Ken and I were working on this way back when, the thing that I didn't understand why that was important at the time is what we're talking about now, is that one size doesn't fit all. And particularly from the network operator perspective, and this is kind of what hit me in the head last week too, was we haven't learned from OpenStack, right? It's VM, forget about Kubernetes for a minute. Let's rewind a little bit. Remember the fervor around we need VMs everywhere because that's the only solution. We're kind of making that mistake again today, saying, wait, forget about all those VMs. And this comes from my perspective. Like, I work with vendors that are trying to rapidly convert their thing in their application, like you're saying, which might have been in a VM, but was probably a monolithic PNF before, right? And it was entangled in the operating system and everything like that. So these folks are asking themselves now, like, what's the point? Like, if I really need a bare metal situation, why don't I just at least just run it in KVM, as a VM, and then then you're done.
And if you want to throw the scary into that, then let's look at this with, say, a 10-year horizon rather than, what we're doing today and tomorrow. 10 years ago, when VMs came on the horizon, I will build it in VMs and this will last forever because everybody will use VMs forever. And then we worked out that actually it turns out containers are kind of useful for this stuff as well. So VMs are, in their twilight years, and we're looking at how to do this in containers. What will come next? I'm not going to suggest, honestly, that containers are the last form factor we find to package applications in, because history's proven that if I were to assume that's true, I would be completely wrong.
You will be
what
wrong
will
in
come
5 years,
after that?
Well, we've
Yeah, I
we've
guess
already got unikernels, right?
If somebody says
they've been around
unikernels,
for
they're
a
going to
few
have to
years.
drink.
Yeah.
Dave said,
Yeah, and we've had
Dave's
sandboxes
drinking.
in the past.
Thanks, Dave.
I mean, I know Kyle loves his eBPF. You might argue that's a form of sandbox, for
Well,
instance.
yeah, I mean, you might
something
maybe it's cyclical. Maybe we go back to bare metal. Maybe mainframes are what's next.
That's
Go
what I'm
back to
saying.
that.
In some
Yeah.
use cases today, and they're very prominent ones, there are TV commercials about this stuff I'm talking about.
Well,
They're moving to bare metal because, it's like the way I look at it is there's a bunch of variables that you slide around and optimize for. And one of them that we often forget about is form factor. We just say, well, of course, we're going to run Kubernetes and the whole enchilada on this thing. And then what we realize is it's kind of like the process swapping problem, right, that we all learned about in operating systems class as an undergraduate. At some point, the overhead of swapping prevents you from doing actual work. The processes are swapping so much, they're not
I'm going to
actually
use
doing anything.
90% of my compute for
Right.
orchestration.
So if you have
10% to the user.
your form factor is small enough, you rapidly get to that point where all I can do is just keep Kubernetes running, right? I mean, you're going to give 0 CPU time to the containers, and that's
And
kind of
when
where
you're
I'm.
talking about IoT,
there are other problems
potentially
there
on
as well. If I'm in a
satellite links.
if I'm in a time sharing system, which every Linux kernel is a time sharing system, and it's busy preempting things, and I need fairly accurate real time behavior, and I always do need some degree of real time behavior. I've got packet buffers that I don't want to fill. So if I basically
Add that
stop
in too, for
processing-
sure. Real time behavior. Make this
Yeah,
even harder.
but if I'm starting to control, as we are seeing now, mobile radios, then mobile radios are quite sensitive to delays in the sense that they stop working.
Right.
If there's
That's
too
one
big
of
a
the
delay.
use cases I'm referring to is controlling
Yeah.
a mobile radio, which it's that problem like 20 years ago when we were building routers, software-based routers, right? You don't service the input queue, messages get old, and the amount you're wasting your time again processing them. You might as well just throw them out.
And I think people forget that if I'm in an NPU, a piece of physical hardware, then it will forward traffic nowadays easily at line rate, and it will drop traffic without really giving serious consideration to what it's doing. That's fine, it's built to do that.
Yep.
In a software system, if what I have is too much incoming traffic, I actually have to spend CPU time to drop it, which means that if somebody's flooding me with traffic, then I'm not going to pass as much as I can pass. I'm going to pass somewhat less than you might expect from a physical system, because I actually have to think about which packet I'm going to choose to drop. I have to discard it. Active decisions are being taken.
Yeah, that's how you get wedged.
Yeah.
Too much thinking about what you've thrown away.
Yeah. But I mean, what I would say on the bare metal debate is what we're trying to get to here is dragging my way away from the hardware at least a little bit, making hardware fungible, making it so that I don't care which hardware I'm running on to an extent. Now, the problem is that what we're doing here is we're trading performance from independence. If I want performance, then I would go for the bare metal. Not only would I get a server, but it would be this memory, it would be this, I might
But
even
there's
care
no
about
free
the top
lunch,
rate of
right?
memory.
That's what you got. That's
Yeah.
it.
Whereas if I want just a little bit of independence, then I'll say, well, any memory will do. I will deal with the processor I get. I need, however, to put an SLA on this. I need to tell you how well or badly I'm going to perform in that environment.
But this is the thing with the edge. This is what I'm getting at. Exactly this. There's a tension between these effectively scaling variables, right?
Yeah.
And if you make a choice, you got to live with, there are, for example, edge RAN cases where you can only fit 6 servers in a thing.
Or what?
And
I mean,
those are either going to
down.
be bare metal, or if you want generic compute, we can put those in, but it costs more power, more, you know what I mean? And what I'm trying to get people to do is to really to realize that there's not one answer to this question.
Yeah, it ultimately comes down to money. Everything comes down to money. If I'm putting a RAM together, I mean, the RAM that we put together a couple of years ago for someone, I think it was, the number varies, but let's go with thousands of sites. That much is clear. I'm trying to balance a number of things. One is hardware cost, because if I multiply any hardware cost by 1,000, then, a couple of dollars makes a difference. So I'm trying to find generic compute and also accelerators, because it's actually RAN is a hard problem, as it turns out. And I'm trying to find a balance of compute and accelerators that ultimately minimizes the amount of cost that I'm spending on that hardware. But I'm also trying to deal with orchestration. The whole thing needs to be fully automated. These things need to behave exactly the same as each other, because I can't give, loving attention and care to each individual one of several thousand sites. Can't be done. Yeah. And I also need to preserve a little bit of flexibility, because if I'm doing a rollout of several thousand sites, then when I get to the end, then hardware has moved on and I want to use newer chips. So that fungibility makes a difference. I want to deal with the old servers and the new servers as if they're the same as much as I possibly can. So,
and the new servers too might change the power cooling mass as well.
Exactly.
Right?
Well,
new server might be more power, and it's not what
or it might be less, and I might be able to stuff more in as well.
Or less.
I mean, power is a significant consideration in these edge sites. I might have a 40 rack unit, 42 RU rack, so I can fit 42 servers, well, give or take 42 servers in there. But I'm not going to fit 42 servers in there because I probably have 4 kilowatts of power, and that doesn't get me very far.
Yeah. So I mean, this is getting to the point where I was hoping it would, which is the answer is complicated. I mean,
there are a lot of variables.
You have to do all the variables and make sure you're getting what you expect. Because what I found is that as you move to the smaller form factor edges, I mean, there are big edge deployments. There's big aggregation deployment, big enough. Where you're not, sort of skimping about CPU cycles or like this much heat or whatever, right? But you get out in the woods in a fiberglass hut that has 2 kilowatts of power available, and half of that is spent running a radio. Well,
But that is practically speaking how this works today. I mean, it was Beth, who works at Verizon, I think, always tells the story of a radio site on a hill with no accessibility. If anything was going to be replaced up there, someone had to hike up the hill and
get up on a mule
with whatever it was in their backpack. There are a lot of variables. We're trying to minimize complexity, minimize the amount of software that we have to develop, because frankly, fine, I work for a software vendor, right? I sell software to other people. They can tell me to make it in 6 different ways for 6 different circumstances. But in practice, that isn't going to work well for anybody, because it will be 6 different sets of bugs. It will be, 6 times the development cost. It's not going to fly. So we're trying to reduce the what we deliver down to ideally just one form factor that we can deal with. But it's going to have to work in those 6 circumstances. So it's an optimization question. And, as computer scientists, we love optimization questions, but they're never easy and they're never solved. You can't solve them in real quantities of time.
That's why the pay is the big bucks.
Best.
Yeah.
The only thing we like better is naming discussions. That's it.
Right.
Better than that, we like adding new layers of indirection.
Oh yes, there's nothing you can't solve with another layer of indirection. But
and so that kind of I think we tend to get wrapped up kind of focusing on the technology when we're developing these things and don't really think about the user. Because so let's just break down NFV super quick here. I'm the guy that pounds the table for the user out there, I think. So we're looking to take black box, aggregated, really expensive hardware, custom built, purpose built. That's generally managed one box at a time, and we're trying to say, okay, we're going to disaggregate this across thousands of sites. But we also want to make the management of it simple, just like it is in a Kubernetes environment for the application developer. So while nailing up, a tiered app, we're trying to say a tiered app is the same thing as a distributed firewall or a distributed load balancer across thousands of sites. When, we're talking about kind of these bumps in a wire, they're disaggregated at a site, but there's still bumps in a wire that are pretty custom to all those sites, right? So we're going to have different addresses there. There's a lot of different variables there that I think are kind of hard to kind of gloss over. So back to does Kubernetes really solve that? Is it generic enough for us to solve it with that sort of orchestration? Or is it just going to be like a standalone, yeah, there's going to be Kubernetes running there, but it's not going to necessarily be part of this larger
Well, your
cluster for
example
NFV.
earlier, Ian, right? Stick a firewall in the middle, maybe, right? I mean, Kubernetes' whole model is a proxy model, right? What happens
Yeah,
if you stick the firewall in there and it stops?
I think there are two different things you're talking about there. The first one is, there aren't many circumstances where what I try and do is spread a single application, if you like to call it that, over an enormously wide area with many compute sites in it. The most exciting thing we ever do with apps is, basically put identical components in 3 places and load balance across them, which is not distributing an application. So that is a problem. Is Kubernetes the solution to that? Does Kubernetes have to be the solution to that, to be perfectly honest? Is it just a part of the solution, right? If I'm building a system architecture and Kubernetes solves one part of my problem, I might consume it, but I wouldn't expect it to necessarily solve my wide area distribution problem. If it basically gives me compute in individual locations, I can use it to do just that. And then I need more. Now, whether I build that into Kubernetes or build it independently is a design decision, and I can choose. The other one about Kubernetes networking, I think, is there is a networking problem here that is not the one that Kubernetes set out to solve. It involves making the infrastructure networking, the platform networking, be really trivial, to be perfectly honest. I mean, the simpler it is, the less opinion it has. The more it's like actual just, copper wires, the less it tells me that, yes, well, you're running it through a switch, so MPLS won't work because MPLS you can't switch. The more simple it is, the better for this use case, but not for the application use case. And attached to that idea is that I'm trying to run a network system as a whole, not just the software, but there's a wide area network in this. I don't control wide area networks like Amazon does the networks between their virtual machines, and I don't control data center networks like that either. These are specialized kinds of networking with actually specialized ops teams as well. So the question is not, how do I make Kubernetes do all the networking I want, or how do I fit it into Kubernetes' current network model? The question is, firstly, how do I make it so that I can get these teams to cooperate and collaborate to deliver what I want? Because they've each got their strengths, and I want to maximize those strengths without basically making them fight over who controls the data center this week. And the other part of the Kubernetes part of this is, what do I need Kubernetes to do for me? Given the CNI plugin model of Kubernetes networking it's very focused on a single use case, and that's good because it solves that use case very well. The question is probably, how do I use it for what it's good for, and how do I add to it to make it good for the thing that I want as well? Which there are different models of thinking.
It gets into the stuff I was talking about. You have to. There's a lot more considerations than that simple use case, which is I need a virtual Ethernet whatever and an IP address and off I go.
Yeah, I sometimes don't need an IP address. People forget exactly how you really do end up reducing the network down to bits on a wire by the time you've finished.
Yeah.
So my personal view, which is subject to change, quite honestly, give me arguments, give me evidence, and it will probably change, is that the CNI is fine as it is. It does, and the fact that it's relatively static is a fairly strong indication that it's doing the right thing. And I have components in my application that need to basically pass control messages among each other, and it's good for that. It does the job. So let's not change it. Let's not try and make it do everything. Let's leave it to do what it's good for. But what we also need is a networking in parallel, which is the really raw, basic kind of networking that allows me to enable very simple wiring to, the top of rack switch or router, which I probably also want to get to do magic for me because it's better at some things. And the WAN, which I want to do magic for me because, things like, traffic engineering, fixed bandwidth connections, it can do for me if only I will let it. So I rather expect there to be, 2 flavors of networking, the elegant and easy to use for application purposes and the raw and basic, which I need for my wide area network collaboration kind of side of things. Again, opinions vary. I can cite any number of open source projects that are basically saying you should do it like this. So it's clear that we haven't got just one answer there, and it's not clear which of those answers is correct, or indeed if any of them is correct. But the fact is that we do need to take a step outside of our comfort zone here and say that just because we've got one sort of networking, it isn't the right answer for literally everybody. I could say the same in storage, right? Amazon provide me multiple sorts of storage, and some are right for some purposes and some are wrong. I choose the one that I need.
And I think it goes back to what Dave said earlier, which I want to make sure it doesn't get lost, right? These abstractions come with a cost as well. And so if you're taking on an abstraction or platform layer like Kubernetes, there's a cost to it that you just, there's an implicit cost. You also need to, and that also ties back to what Tom was saying earlier with the bare metal discussion. That's one of the costs, because in terms of what Tom was talking about, the cost is legitimate. You're using up some of your very limited CPU budget in that case for the orchestration system. So it's a very measurable cost for what Tom was talking about.
Well, even Brent's point, right, and what Tucker was saying, that actually has an operational cost, right? That's not free. I mean, my point is, like, go into these conversations with your eyes open, and like Ian's saying, do the math. I mean, this whole system is fungible enough that you can, you can manipulate the CNI if you want. You can plug in different networking stuff. You can have different, mesh trees on top of that, depending on what you want. But you got to know what you're getting into. It's not. There's no free lunch here.
And that brings us full circle to Kyle's original comment about Etsy. The thing is that if you can do it anyway, then there are no standards. But there need to be standards because people need to understand what they're working with. I think the distinction
what to ask
here,
for, even.
Yeah. The distinction here is that Etsy was a standard. It had its strengths and weaknesses, but it was a standard written by network developers, network architects, to basically say, this is going to cause us a bunch of problems unless we get you to build components that fit into slots that are recognizably a thing. And they weren't wrong on that. You did need to understand that. But I think what it meant is, before we actually understood what worked and what didn't, because we hadn't actually written the code and we hadn't done the experiments, we laid down the law of what they were going to be. This time round, we haven't actually gone down the standardization path quite so strongly, although, I mean, I'm working in the community in various areas of what could be a good idea. So we've got the opportunity to actually say, this works, this doesn't work, this works better, and get to a place where we do have a standard. I understand what the platform is providing me. I understand that it's enough for me to get my job done. But if somebody makes an application that needs something new and different and extra, then I have pushback. Justify why you want this. Justify that this should be added to that standard. The standard can evolve over time.
And I kind of think that's where we are in the innovations curve too, right? Like, I think the tools are out there, the basic building blocks are out there. We're kind of arranging them to find those sweet architectures that reference architectures. People are pretty reluctant to kind of standardize on reference architectures right now, obviously, because everybody's competing there. I think I do feel more optimistic about the state we're in now than all of us were in 5-10 years ago when it was OpenStack. Like, yeah, we're rearranging the chairs on the deck, but I don't think it's necessarily that Titanic.
Yeah.
Well, I think the most there's a lot more understood about what we're trying to do,
right?
Versus starting off on a whiteboard and saying, "Yeah, this is like the Etsy thing." I mean, the Etsy picture, which survives today, was a good go at that, right? But
yeah, we're trying to get to the point here. I mean, almost the whole point of this, in saying we will use Kubernetes as our platform, is to say that Kubernetes has a vibrant ecosystem. It evolves, it moves, it develops best practices. I mean, to take an example, right? We started with the orchestration built into Kubernetes. We moved on to Helm. We've talked about controllers. So it didn't just start and then stop, right? It's moved over the course of time. And we almost forget this because we were living it, and you always do the thing that is best at the moment that you're doing it and pretend that nothing else ever existed. But the reason we want to use Kubernetes is precisely because it gets better, because it's doing a good job, but it's also moving forward. We want the best practices to come to our side of the fence to help us do our jobs. So you can't have a standard that is rigid and set forever. You've got to have something where what is best is not always best forever. It's best now. It's the best thing we know about.
Yeah, I agree. I think those are almost words of wisdom. I feel like we're kind of wrapping up our time here. This is excellent. Those are great words to kind of end this with, I think. We're always moving forward. And I think it's going to be great to have you on in the future, hopefully 5 years down the road so we can all talk about,
When
reminisce
SDN
about
reemerges.
containers. Yeah, exactly. Yeah, exactly.
I might be living somewhere with no mobile coverage explicitly, so that I
Well-
never have to think about this again. You never know.
We can play a game of spot the raw networking project in the CNCF landscape 3-page.
I like
If
it.
it's one of those 100 logo slides, then we have a problem.
I like it.
Meltdown on your machine.
Well, Ian, thanks for joining us. It was great having you on. Excellent discussion. And to
Really
those
enjoyed the
listening,
time, actually.
thanks. Yeah, we'll
Thanks for
look forward to
being on.
having you on in the future. And to everyone listening, thanks for listening with us. Make sure you check out the website, subscribe as well. We'll try to bring you some more interesting content every week. Thanks a lot. That's a wrap.